I think a lot of credit goes to OpenAI because they created that whole shift in the market. Now you don't need to build AI, you are going to build with AI. This is a very interesting decade where human becomes the center of the technology. And not many people realize that because you don't need technology to again do AI governance. You need humans. Humans are going to be the center of this decade's technology. I think it's important for us to build the right kind of skills that are necessary for that period of downturn. Problem solving skills coupled with how you use these technologies to empower your own decision making. If you have these two skills, I think you will always find place in any kind of an enterprise. At the end of the day, we are all going to be measured on our productivity and outcome rather than how many hours you were in office. Humans cannot be replaced. There are still, intelligent decision making that only humans could do in a more effective way. All roles, irrespective of whether they are a software engineer or data engineer, they will have to adopt to AI technology and understand. The people who are curious and who are bringing in that full stack expertise will get more opportunities to work on cooler projects.
Hey, hi. Welcome to yet another episode of Scalar Pod. And today we have with us Muthu, who is Global Head of Data Science and AI at Brilio. Thank you for coming. Thank you for spending your time with us. I have a lot of questions on Gen AI, which is like in vogue these days. So I'll get to it. I'll probably get started with the question, which is sort of like the icebreaker question I ask all of my guests, which is, what does a work week for you look like? What all things does someone at your role need to do at Brilio?
Yeah, that's a great icebreaker question. So there are like three primary roles that I play in Brilio. One is, of course, working with our customers and solving the business problems. So since my role is part of the global head of data science and AI, most of the problems that I solve for our customers will involve AI solutioning.
Right.
Now we are doing a lot of AI strategy and governance, work as part of the solutions because that takes front stage with a lot of regulations that are coming up in the market today. The second part of it is definitely, the execution of the solutions that we build for our customers. So in the execution part, I directly work with our customers on blueprinting the architecture. That also comes with the talent lifecycle because we need larger teams and very different skill sets to execute some of those projects. So I do manage the talent lifecycle as well. And third, of course, is the innovation part of Brilio, where we keep looking at what is happening in the market. We try to draw patterns with the different problems that we are solving for our customers. And we look at what kind of accelerators would make sense for us to build these solutions and take them to the market faster. So the third aspect, which is the most interesting part of my job, is the innovation-led labs.
Right. Nice. I can already see that I have a bunch of questions on this, especially on, I'm sure you get asked about like when you are applying AI to solve for certain problems, does it actually reduce the number of jobs at a place or not? I think it's an important question that people definitely ask, I'm sure, and the governance bit as well. Right. But I'll come to those questions. But before doing that, I would love to get to know a little bit about your journey in tech so far as well. Like, what got you interested into technology, and then last, probably a decade or so, what all things you have been up to.
Sure. I did my engineering most of us in our generation, we start with studying some engineering. So that's the mistake that I also did. But then I realized very quickly that the electronics engineering it's not so much for me because I am more of a number cruncher and I had more affinity to understand patterns. And I really enjoyed my school up to 12th standard. I still, loved education. But the 4 years probably, it was not really hitting with me. That's when I got an opportunity to work with Mu Sigma as a business analyst. So my first job, so we got out of our college during recession, the 2008, which was also a very fascinating area for us to start analytics because that's when a lot of Fortune 100 companies back then started exploring analytics, looking at how can we use statistics to solve business problems. So I was very fortunate that, my first job itself had a lot of very interesting analysis where we looked at macroeconomic variables. How is a recession going to impact sales? Can we predict what are the variables that are going to really have an impact on the revenue, on the profitability?
Right.
So that's how my career started. So that was a pretty good jump start for me to transition from analytics into data science, like a few years from then.
Right.
When we moved from SAS to R and then to Python in my first decade of experience, where a lot of things also changed, right? When I started in 2008, we used to be very happy with survey data, for example. Like the data was very small,
Right.
and whatever impact that we could generate from those small data sets, it was still okay. And but the sales cycles were pretty large because you had to explain the importance of analytics to a lot of businesses. And there were industries which were using analytics pretty well. Like, for example, banking, insurance, there were a lot of fraud reduction models. There were a lot of, logistic regression models that didn't need so much selling.
Right.
But then if you look at across industries, if you see, analytics was not very prevalent, right? So then the second part of my career, was pretty interesting for me, I think, because the market itself switched. There was a lot more infrastructure available, a lot more data available because the world was getting digitized.
Right.
So that really was a turning point for my career when I switched from analytics to data science. Now we have a lot of data, we have the infrastructure, now we have algorithms that are available that can churn out insights faster. And that's where a lot of businesses started seeing value in data science, and there was a lot of adoption of data science into different business groups, different industries. And last couple of years have been way more interesting than the previous years because of this whole AI hype in the market. I think a lot of credit goes to OpenAI because they created that whole shift in the market. They created a lot of FOMO in Q1 of 2023. Even some of our customers who didn't even have a proper data strategy were now asking us for a AI strategy, a Gen AI strategy, right? So that was a pivotal shift in the last couple of years where we are looking at how you can use generative AI. Now, in addition to classic ML, generative AI has also become very popular, where we could, see a lot of results quickly because, now you don't need to build AI, you are going to build with AI because the foundational models are already built and solved by hyperscalers. And now we have a lot more applications that we can build on top of this. So this has transitioned, the way I look at the skills that I want to develop also as, an individual person, right? That's where governance frameworks become a lot more important than what it was before. Because say when you use a classic ML, you would still know where your results are coming from, and you are still able to, make more predictions with a lot more comfort and confidence from the way the algorithms are designed. Today, we are using foundational models, and the data that was used for building these foundational models could be across the internet, right? So now
provenance is very less on that. Yeah.
There are a lot of techniques to resolve that, but now there's a very interesting decade where human becomes the center of the technology. And not many people realize that because you don't need technology to again do AI governance. You need humans. Humans are going to be the center of this decade's technology, and that's why I'm very excited to see that this era is just getting started, and it's going to be very interesting over the next 20 years on how AI is going to get to the next level of AGI, and how it's going to empower the humans with human intelligence getting to the next level.
Interesting. I'd have a few follow-up questions on your early stages of your career as well, because you're telling about so Mu Sigma itself was a very small company then, I'm sure. 2008 you're saying. I mean, they are obviously one of the leaders in the space now, and I see a lot of parallels to what you're saying, is that it was also like the turn of a recession at that time. Like a lot of people who are graduating right now probably going through
Hmm.
similar emotions, because we have had a downturn in the industry right now. And again, like you were saying, like there was a shift towards products starting to use analytics and data science becoming like an upcoming thing. I think the sprinkling AI into a lot of workflows, that's sort of like a major shift these days as well.
Hmm.
So like the industry is in a shift. There is like a bit of a recession also. Any any particular advice from your experience back in 2008 around people who are trying to start their careers in tech right now?
So if I try to draw parallels between what happened then and also what is happening now, I think it's important for us to build the right kind of skills that are necessary for that period of
Yeah.
downturn, right? I
Correct.
wouldn't really call what we are going through a big recession.
Yeah.
It's still not there yet, but then you can still see that a lot of companies and large enterprises are evaluating what skills are required in the enterprise versus what skills are not required.
Correct.
And a lot of times, I'm not generalizing it, but in most of the scenarios where problem solving skills coupled with how you use these technologies to empower your own decision making, if you have these two skills, I think you will always find a place in any kind of an enterprise, right? Because we over the last couple of decades, we have put a lot of emphasis on coding and learning the technology and showcasing our power of remembering or the memory of our syntax. And it's also because how we are taught in schools and how we are tested on our memory more than our logic, right? So we are also tuned to thinking that if I remember the syntax in my interview, if I'm able to showcase how this code executes in real time, I will be able to land on my dream job, right? So that is how we are conditioned because of the ecosystem that we grew up in. But today that is shifting, right? Because a very simple code is something that you can generate using AI itself. So I think 2-3 things we will have to still learn. One is on how do you structure a code? How do you think through what kind of architecture pattern will work for a scenario? So that learning from a technology point of view is still very important. The second aspect is about where to use the technology available, right? If something can be copy pasted from anything that's available in the market, or if you know how to search for a code without having to write from scratch, I think that is a good skill. And using code assistants like a Copilot, a GitHub Copilot, that is also very important, because at the end of the day, we are all going to be measured on our productivity and outcome rather than how many hours you were in office, where you logged in for 12 hours. No, that whole culture is going away. And this is going to be the most important thing. And the third aspect is we should be able to communicate very effectively. Right now, as a developer or as a data scientist, whichever role that we play, right? The primary part of my job as well to my customers is to explain and articulate the business value of doing a particular problem or a solution or architecture, right? So communication and articulation clearly is going to be another primary skill that every person is going to need, which also we were discussing before the podcast that back in those days, techies wouldn't communicate much, right? So like, okay, I did my code, it executed fine, my job is done, right? So that phase is also gone. You should be able to communicate. You should be able to articulate. More than communication, it's about articulating very clearly. Why am I choosing this code assistant? Why am I building a model from scratch? Or why not? Why shouldn't I build a model from scratch? Why should I use a model that's already available? I'll just do a simple prompt engineering, right? So these are the decisions that we should be able to take. And we should be aware. Right now, even AI is context aware, but so as humans, we have to be way more aware of the domain that we are working in. What kind of businesses will really give us that, kick and passion to go and figure out the technology to do that job correctly, right? So that will also be one of the primary things that will really, help a candidate stand out in companies.
So another thing, like in your you were saying early part of your career, people were moving from like taking survey data and doing analysis, just like, plotting graphs, to what we know as the modern practice of data science, right? So from then to now, I mean, data science is something, at least in the technology space or in the product space, you don't need to tell somebody that what data science is anymore, like, and that whether a large technical operation needs to have a data science practice or not, that's also something that you don't need to tell people. I mean, it's become very ubiquitous in that nature. And you have seen this journey. So what has changed also in the world of data science from its early conception phases to now?
I think the foundations of data science has not changed much, I would say, right? So the life cycle of a project still remains the same, where you will start with understanding the problem. Then you look at whether, so a lot of times we struggle with converting a business problem to a data science problem or an analytics problem, right? Because qualifying that has always been a challenge.
Right.
Because I have seen customers where there'll be only 30 respondents to a survey back then, right? Like 2 decades back, they would ask us to build a story around it, right? And today also I see that there's a lot of data, but there's a lot of bad quality data.
Correct.
And we are expected to, build a story around it. And even if we build a story around it, there'd be no trust in that story, because your data is bad, right?
Okay.
So some of those challenges still exist. It's just the volume of that challenge is a little different now. The scale of the problem is a little different now.
Right.
And the type of problems, like can you really use statistics to solve a problem? Or do you need statistics to solve a problem?
Right.
That is still there, right? Today, lot of simple solutions, like say forecasting, or I'm predicting whether somebody is going to have a footfall today or not. These can still be solved using classic AI. But there is just a FOMO in the market that we want to use generative AI for everything. Like when some of the customers might ask, hey, can we build a generative AI solution for this problem? So we go back and educate them on why they don't need generative AI. And in some cases, you will not be able to solve it using generative AI as well. Like a deterministic rules-based solution, could very easily solve that problem. So these kind of challenges on converting a business problem and qualifying whether you need data science or AI or what type of AI, that is still existent, right? Then the second part is, of course, data preparation. This has changed a little bit, right? Now, back then, like I said, the data was small. So we used to do everything, right? We used to collect the data, we used to gather, we used to put everything together, create a data model, and then build the data science models. But today, the data is huge. There's humongous amount of data, and there are very specialized, skills that are available in the market.
You can't manually
today.
put it on an Excel sheet anymore. It's
Correct.
not that size anymore, right?
Correct. So you have data engineers who will use different kinds of, compute. There is a data architect who will be able to put together. The data modeler will come in and say how the data model should look like, for what kind of solution you need, what kind of data model. Say there are 10 data scientists trying to solve 10 different problems, then the data architect and the data modeler decides how this should be structured so that they can rinse and repeat without having to have different siloed architectures. Now we have different kinds of data architecture patterns as well, like data mesh. Should it be centralized? Should it be decentralized? So this whole data engineering part has become way more advanced. And I believe as AI continues to grow, data engineering will be one of the skills that will become way more important, right? Because whole data monetization or data migration using AI, this is just powered by AI, right? But the AI is just an enabler to do data engineering, but data engineering and good quality data will continue to be the primary factor for the entire life cycle. Now, this is like very important because a lot of people think data engineers will not be needed in future. So I just wanted to emphasize on the fact that there are going to be a lot more data engineers required to do some of these aspects. Now, the next part is building the models. Now, this has changed a little bit, where the choice of models that were available in the market was not as high as it is today. Right. Now, while we all talk a lot about GPT because it was very popular and that created the wave, a lot of open source models that came into the market after this in the last couple of quarters which are doing way better. The performance of these models are also way better than the GPT models in some of the use cases. So that is also, something that has changed over the last, like couple of years. I would say this the choice of models are higher. Then comes the scaling part. Now, 2 years back, there was a ML engineer and there's a data scientist. So data scientist will build model, and then ML engineer will productionize it, and then they will integrate it with the product. Now, this is also, merging, and we have more full stack, specialists who, because you're not really building models from scratch, right? You either prompt engineering, or you do RAG, or you do fine tuning. So this whole scaling has become part of your life cycle. You just cannot build a solution which you cannot take to billions of customers later, right? So now that has also, merged, and it has become a big part of our life cycle. The next part, which is the valuation, which used to be done only from a quantitative perspective. Right now, if a model performance is good, then I'm good to go to production, right? That is how it was in the past. But today, that is not the case, right? So you will have to look at what kind of regulations, what kind of parameters. This all were very prevalent in the banking field all the time.
Yeah, because that was always regulated.
Always regulated, right? But today, everywhere, healthcare, life sciences also had some gray areas, but today everything needs a proper regulation, governance layers, even retail verticals, right? Even when we are trying to do a pricing model for a product, or even if we are trying to create recommendations for a media company, we are expected to look at all the regulations. What kind of variables are we using? Now with deep learning models, you don't have that liberty to say, okay, this is how my model was built. So there are other advanced techniques that are available where we try to look at okay, now the model could be good when we are building it and when we are testing it, right? Now how will we measure the toxicity of it when it starts self-learning after you put it on production? What kind of drifts should we monitor for? There are again different kinds of drift, like data drift, concept drift, with respect to domain as well. If there are bigger shifts in the market, so how are we going to take care of that from a regulation perspective? Because you don't want AI to learn from bad patterns, or maybe our historical data was not distributed enough from a gender perspective or from a ethnicity perspective, right? So how do we tackle some of these things before it goes to production has also become a very, very big important part of the life cycle.
I mean, even large companies have had like FoxPass moments where they have launched pretty large consumer-oriented models, and then like in the wild, it is figured out that, okay, there's a certain vector you have not even considered when you're building the model. I think these things are, as you go further and further away from a deterministic world towards, deep learning and then towards generative models, and these challenges will obviously keep increasing, right?
Correct. And there's also, now we have contextual forgetting, hallucination. I'm sure you would have heard these words, right? So hallucination is something like when you ask a question to the AI, which is learned from your data, but it starts giving you answers out of the data that we have trained on, right? So this is happening very regularly on production, right? And you can control it, you can identify it, but you can't build a system that is completely rid of hallucination yet, right? We are still in the process of getting there, but again, all these becomes very important. Now contextual forgetting also is something that we've solved for, but it is still a problem in some of the scenarios where you start talking to a bot, you come back tomorrow and pick up on the conversation, it's forgotten what you spoke yesterday, right? So these issues will continue to exist, but maybe in 1 year down the line, we might have, systems that are completely rid of it. But again, even when we reach that stage, from a regulation perspective, I think we should have these monitoring in place. Because the more we have generalized models that we are using on production, it's very, very important for us to have human in the center to monitor these things. That's why I said in the next decade, humans are going to be in the center of technology.
Interesting. I think I'll quickly dive down into that particular statement that you made about humans. And I think it's something that has been of a concern at, I think, various levels. I think at a end user level, people who are employed in various domains, looking at what sort of risk AI poses to their long-term employment, to I think even governments looking at what does a government of a billion people country does consider about, is there a technology shift which leads to long-term, employment numbers shifting in the country and all. But I would want to very specifically, come to a more nuanced question rather than a, loaded question like, is AI taking my job away, which is sort of, it does generate hysteria. But more specifically, you are sort of on the cutting edge, applying AI-based solutions to problems in the business domain. Do you see most of the solutions lean towards tools which help people become more productive, or are there places where it's more like, replacing humans from a pipeline?
I don't think, like I said, right, humans cannot be replaced. There are still, intelligent decision making that only humans could do in a more effective way. Like, for example, emotional intelligence or social intelligence is something that AI will take a lot of time to learn and start replicating how a human would think about an emotional intelligence or a social intelligence, right? And we are all connected beings. So I don't think a technology will replace, all of the scenarios. I'll give you an example, right? In the last 1 year, a lot of, transformations happen in the contact centers where instead of having human agents, we are trying to look at how AI agents can start interacting with the customers.
Correct.
Now, as customers, even we have, started with a bot, but even before the bot response, we would have clicked on talk to an agent, right?
Correct.
Now, I have done that multiple times because the trust in, completely, putting the trust in a technology that as humans, we will take some time to get there. And second thing is, there are some conversations that you would feel better when you hear a human voice, because you will feel more comforting, which how much ever we try from an AI perspective and have multimodal models, those scenarios you wouldn't want a AI agent, not because AI is not capable of it, because it's just insensitive to have AI handle some of those conversations with the customer. And whenever customers are already at the peak of their frustration and their probability of churn is very high, those scenarios as well, enterprises will not look for AI agents. You would still want a human agent who will be able to build the trust, give that whole comfort from the different aspects of humans, right? We have voice, we have facial expressions, we do some actions, we try to connect with personal stories. I think AI will take some time to reach there, but definitely a lot of mundane tasks that, we were doing, those will definitely be taken up by AI. So maybe, it will empower humans. Maybe all of us don't need to work 5 days a week. Maybe if it makes us work 3 days a week, it is still better. But I don't think it will ever replace human intelligence. It will take a lot of time for us to reach there. And we still have a lot of studies that are going on today. I recently met a AI anthropologist, a AI psychologist, and they were talking about the different kind of studies that are going on, because most of the tech companies, and as technologists, you and I will have a lot of positive bias towards technology, right? So these roles are going to become very prevalent in enterprises, because they are going to question us. They're going to put us on the spot and make us take decisions which will not impact the whole ecosystem of humans, rather empower, humans to do their jobs more quickly, I would say.
Makes sense. There's also typical, I would say, risk I see with extremely consumer facing AI deployments is, like you were talking about these hallucinations and also like prompt hijacking, and also few popular consumer companies recently have tried putting either some open source models like Mistral and all, but some of them have even used just a wrapper over GPT and made it their customer service agent. There have been examples of people putting screenshots on Twitter where you can sort of, somebody asks for a refund and they say that as per our policy, we can't refund after 24 hours. And then somebody just replies that your policy is wrong. And then the bot just says, yes, the policy is wrong and we can refund. And then, so the problem is that obviously maybe it won't lead to actual refund happening because the bot is not empowered to trigger the refund. But then for a consumer, it's still voice of the brand, right? When you're talking to that agent,
Right.
I mean, because you're advertising that this is my customer support agent, whether it's human, whether it's, GPT, but you're saying this is your agent. And then somebody can just show that screenshot and say that, hey, on an official channel, you say that you can refund. So I think those risks remain. And I think that they have increased with generative models because this is like typically a scenario that does not happen with more classical ML text generators, right?
Classic ML also will always have any data science analytics or AI models that we have. We don't have 100% accurate models.
Obviously,
right?
yeah.
So it will always be 80% accurate or 70% accurate or 95% accurate. If you fall in that 5% bracket of non-compliance or the model did not train on a pattern like you and me, then we are going to be in that bucket, right? So I don't think we will ever reach a stage where we are like, we have an AI which is 100% perfect, right? Like there is no benchmark even with humans that this is right and this is wrong. Everything around us is a gray area. So if we as humans are training the AI, I think AI will also be in that gray area.
Makes sense.
But what I have seen in my experience working with a lot of Fortune 100 companies is that AI is used primarily in the back end today because that's
like
where
Copilot kind of things,
Copilot kind of things, because you just want to do things faster rather than for AI to completely take decisions with the customer. So front end productionization is very, very less, right? Because like how you can use AI to automate, as customers also can use AI to generate images that are not true, right? So in these scenarios, the AI testing or testing of the content that is generated around us will also become a very big, important aspect.
Makes sense. Speaking of like, usage on the backend and then Copilot kind of things. So, I have, seen this sort of statement around on social media and even on memes that, your job is not going to be taken away by AI, but by somebody who uses AI better than you.
Yes.
Right. And, let's say even I'm starting to see some of those things. I mean, we recently had gotten GitHub Copilot licenses for our team, and some of the folks had not even activated their license, and I started to push them that, hey, come next, review cycle, your peers who are actually using it, their productivity will start showing up. You should actually start using it. And I had to start to push some of my team members who were not organically picking it up. And I'm starting to see that difference, like of somebody who was averse to using it because they were not comfortable with the UX, maybe because it's like a text editor kind of a thing, right? I mean, somebody prefers a Vim, somebody prefers a VS Code, but it's like that. And, the way it injects the autocompletes, it takes a while to get accustomed. But when people unlock the power of it, their productivity definitely increases a lot, right? So, yeah, I mean, what are your thoughts on this? Like, does like almost everybody, especially in digital ecosystems, should look towards starting to use AI to supercharge their jobs?
Correct. And it's an entire life cycle, right? One, they need to be aware of what all tools and technologies are available in the ecosystem, right? And at least from a strategic role, lot of C-suites are already investing and they're looking at how to measure the impact of the investment. Like, for example, you rightly said that, hey, you got 100 Copilot licenses and say for 50 employees don't know how to use it or they're not adopting to the technology, then you really cannot have a productivity suite again measuring, what was the value of those investments as well, right? So I think more and more technologies come in. One, awareness of what is happening in the market, reading, at least spend 30 minutes every day on understanding what's happening around me, what is the new cool thing that's in the market, right? People are still talking about GPT-3, right? Like, I was very surprised. A lot of things have happened in the market. So just open up and start reading more, right? There are 7 different types of RAG that are available. I just recently wrote an article about the multitudes of RAGs that are available. Like, it's not just one thing today, right? There are different versions of it that are coming up. So one is awareness. The second thing, of course, is to know how to use it in our ecosystem, in our day-to-day lives. Right now, we are always going to be bombarded with a lot of things, and it's good to be aware. But you don't need to start using everything, right? So knowing where we will have to invest, even for our personal usage, on how to use technology to make our lives easier. So that is second part, where the curious attitude to go and try out and start picking up these new technologies will definitely be the second part, right? And third is unlearn and relearn. A lot of people, when they get into their comfort zone, they just have a way of doing things, right? Like you said, even editors, I've seen that when people join a new organizations and they're like, okay, oh, you don't use this, oh, can I just get a approval to install this? Like, that whole unlearn and relearn is going to be way more important,
Right.
because we are just getting started. So maybe every 2 quarters we might have new development in the market, right?
Correct.
So it's important for us to be adaptable to the technology, and also not giving up on our problem solving and decision making skills, right? Like you said, AI, it still does not decide. It still cannot tell you whether you can reimburse this or not, right? So it's still going to be humans.
Correct.
So how do we quickly adapt and also bring in this whole aspect of problem solving, critical thinking, decision making?
Right.
These are like soft skills that we always deprioritized, which is all going to become the most highest priority for all kinds of roles.
Got it. I'll take a segue back to something you were mentioning. It was in the back of my mind that you were saying about, as the in the domain of data science and data scientists, there is starting to be more demand of people who are more full stack and they understand the data engineering side of things as well, right? And I just thought about what we were saying, because I keep hearing about this from even like Scalar has a major vertical of people learning data science, and often there's this discussion in those forums and the WhatsApp groups I keep hearing about, like whether, like, if I want to become a data scientist, do I need to focus on the data engineering aspects of it as well or not? I wanted to ask that as well, like, in the data science space, like, I mean, you run a data science team, so when you're looking at talent as well, how important it is to also have those, I would say, fundamental engineering at scale kind of skills, right? I mean, how do you handle billions of parameters coming in through a Kafka pipeline, or how do you design a data lake so that you can, store like lots of data cheaply, what sort of format your file should be in? I mean, there are places where these are very different roles. Like, you do have people who are highly skilled in like software engineering per se, managing some of these aspects of your infrastructure, and your data scientists do not need to 100% know how that implementation is working. And I have seen what you were saying, that there are places which are looking for data scientists who actually understand that as well, and they own that part as well. How does the future look like to you?
So I think all roles, irrespective of whether they are a software engineer or data engineer, they will have to adopt to AI technology and understand. Because say within the software development lifecycle, you have co-pilots to do code development. There are architecture patterns that we are able to generate with AI. Then there are like business requirement documents that we are able to generate from your workshop transcripts, etc. Then testing, we are able to do functional testing and performance testing. We are able to completely automate using AI. So even if you look at this, you can specialize in software engineering, but you need to know AI. Very similarly, if there is a very large data migration program or a data engineering heavy program where we are building a data platform from scratch, the data engineering will be the core skill. But they will still need to know AI, because we can do data engineering, or we are doing data modernization and data engineering powered by LLMs, powered by AI, because we can do it much faster. AI can understand the existing, architecture. It can help you put together a target architecture, like very quickly without using AI, you would have taken like a year to do the migration. But today we can cut it down very easily by 40%. 40% is something that I'm saying based on 2-3 projects that, we worked with. Maybe people are able to do more than 40%, but 40% is like a benchmark today for any engineering projects where we are able to enable that process with AI. Now, with respect to data science, if you're specializing in data science,
right.
You, like I said, the whole life cycle starts with problem statement and data engineering. So if we don't understand how to structure the data and what kind of volumes we are dealing with and how scaled this algorithm should be, then they will not be very successful, because we are not building any models from scratch today, right? Like I said, we are either doing prompt engineering or we are doing fine tuning. Now, for us to be able to make those decisions correctly, we need to understand the data architecture very clearly. Like,
Right.
for example, I have a logistics, customer. They wanted to understand, can I forecast whether every hour how many parcels I'll have to deliver at what size.
Okay.
Now, this is the problem statement. Now, if the data is not structured at an hourly level, your model cannot forecast it at an hourly level, right?
Absolutely.
If you have daily, then daily is what you will
the
have.
granularity has to exist in the training data itself.
It's a very simple problem statement, right?
Right.
Now, if I need to get the data at hourly level instead of daily level, I need to make some changes in my data engineering pipeline. Now, a lot of scenarios, you will, if possible, we can get a data engineer for the 2 sprints and then get it done, right? But today, a lot of full stack, data scientists, they want to do it themselves because they want to have the power of structuring the data so that they can have more choice of algorithms based on the
and if you can, then why not?
Why not, right? So I see that change in the the next generation where they're very curious, and the people who are curious and who are bringing in that full stack expertise will get more opportunities to work on cooler projects, right? So it's a chicken and egg problem, right? You can say that I'm only going to build models, but I'm not going to scale. Then the number of opportunities that those skills will have will be lesser in the market. The next part is you don't build algorithms for small scale data at all, right? So there are like small language models that exist, but again, you don't build any solution for a subset of data and then say, okay, I will scale it later or somebody will scale it. So understanding the engineering part of how will this forecasting, like at hourly level, we have designed something, but how should I think about it at scale? Say, for example, there is a drift that has happened and my model is not performing and my model performance has come down my cutoff. Now, you need to have parallel pipelines. You need to have those engineering strategies in place. Like, what is my fallback option? If this algorithms fail, right? So then what will be the deterministic rule that I need to put in place? So say, for example, if it hits a specific algorithm multiple times, you will probably incur a lot of cost. Now, do I need all the customers to go through the same pipeline, right? A very simple recommendation engine, right? Now, if I don't have enough data about a customer, so I don't know what all he likes watching. Now, should I really go through this sophisticated recommendation engine? No, it's a cold start problem. So I will have, some deterministic rule to come up with a recommendation engine.
Right.
And I have done only 2-3 sessions where I know very little bit about you based on what you have filled in your account information. Then we will have a second pipeline, which will be a very simple classic ML model. Third, where I know enough about you, I know which season, what you will watch. In April, May, it is primarily your kids who are going to be, occupying all of your Netflix and Prime and stuff. So,
summer vacation time.
So your recommendations can then be way more sophisticated. You can start looking at, okay, at this time of the day, this time of the hour, this is how. You don't need that algorithm for all of the scenarios.
Correct.
Maybe, 50% of your customers will fall in the first 2 buckets. So the cost efficiency, decision making becomes a very important aspect.
Right.
So that is not an architect's problem. That is not a solution consultant's problem. That's my engineer's problem. That's my data scientist's problem. Today, that's how we are looking at it. We want everyone to take ownership about their decisions. Right? You just don't come and say, this is my architecture. You have architecture patterns defined for every solution. So that is where I think a lot of changes are happening in the market today. And the next gen is very excited about adopting to these technologies. Right now, we don't go and ask people in interviews, what do you want to become 5 years down the line, right? We ourselves don't know what is going to happen in the market 2 quarters down the line. And the next gen is also able to pick up and run fast as the technology is also running.
Yeah, they are more tech native in nature. Yeah. About the recommendations, what you said is, I think that definitely hits a chord, because I know I've interacted with people who look at it from outside and they see like an announcement saying that, okay, we use AI to recommend, let's say, anything like maybe movies and something like Netflix, and people think that it means like for 100% of the users, 100% of the times, the next movie is being recommended by something like a GPT kind of multimodal model or something, but because I actually work in the industry, I know that that's not how it happens. I mean, initially you start off with making like larger cohorts of people. Like somebody just watches cricket matches a lot, you just put them in the sports bucket. Somebody watches like comedies a lot, you put them in that bucket. And there are like default curations that you just have for like large buckets of 3-4 types, and that's purely like if else conditions and humans doing that curation. And then before doing this, you can't start like saying that I will take somebody's watch history and pipe it into GPT and it will give me some magical answers. It just does not work. Like if you actually deploy it for 100 million customers, most of them will be unhappy with what they get. You probably just need to just look at the most obvious set of data and give them the obvious things before you do those more finer things. And obviously there are power users who watch a lot of things and they've exhausted a lot of the catalog, and for them to be able to surface out newer recommendations, sure, a good generative model can do that. But your day one customers, if you give them random stuff, it does not really work well. And also like it costs a lot to do something like this with millions of users, because like something like a consumer level as GPT is like $20 a month kind of a thing. But if you have like billions of users, then your GPU costs are gonna turn you into losses. I have a question on that is also when you look at like a business domain problem, like something you were saying that a logistics company wants to say figure out how to forecast number of parcels, and I think there are multiple such problems in every industry, and forecasting obviously people do want to do because it helps optimize. Somebody in your shoes, or like somebody who is trying to figure out a solve for this, how do you go about evaluating whether, let's say, what do you need? Like, do you need just something like bunch of if-else conditions to solve this, or do you need some sort of AI model to do this? Would you use like a classical ML thing? Would you use generative AI for this?
Right. So whenever we take a problem, right, so we will try to look at what is the problem that we are trying to solve, and how the insights or the scores or what we are going to be generating, what should be the output, and how will it be consumed, right? For example, one of the large retail companies, we were trying to look at how to optimize to load the truck. Like for example, that manufacturing unit that they have hygiene products, they also have pharmaceutical products, and a lot of things. It's a mix of multiple products that get manufactured in the same unit. But when you pack it and when you load it in the truck, you're trying to optimize for different distributions. For example, a sanitary napkin cannot be kept at the down, it has to be kept at the up. There's another food logistics company that I used to work with, where like say tomatoes cannot be kept at the bottom, it has to be kept at the top shelf. So even within a truck, we have built very sophisticated models on how it has to optimize for this space, etc. But now look at the consumption, right? Now, who is going to consume this thing? The persona who's going to consume this and who's going to actually keep stuff in the truck, he's not going to understand the results of our model, right? So we should be able to look at how is this going to be consumed, and how am I going to ensure the adoption of this is close to 100%. Because say if we create a chatbot for a quick service restaurant and customers just want to order it in front of some person, right, then the chatbot is really not necessary. And today we have these QR codes which work perfectly fine. So why do you need a chatbot, right? So the first part of the whole discovery, this is what we call it, a
Discovery,
discovery
yeah.
phase, where we ask these questions. Hey, do you think the person who's going to load the truck will understand the output of this data science model, right? And for this person, can I put it in a chatbot format where he asks questions and then you give answers on what to put in the first
the UX
row.
is also important, right? And
Right.
who will be using it, yeah.
Correct, right? So this whole consumption layer becomes very important. And the second part is feasibility. Right now, we have a problem, we have a solution, everybody's happy with how it's going to be consumed. Now, is this even feasible for us to do? One important aspect is the data, like I said, right? Now, if you don't have the data at the right format, like you have been traditionally loading things, but you didn't really keep a track of what went into, which truck and what is the route of the truck. If we don't have those data sets available, where will the AI learn from, right? So that becomes your second question, which is where we will say, okay, let's do it the deterministic way with if-else condition, see how people are adopting it. I'll start collecting data from now. And then you get into classic ML or, traditional AI or generative AI based on how they are adopting and what kind of data we are able to collect. Now that becomes the second aspect.
Right.
Now, sometimes customers will say, I have a lot of data, but the data will be bad quality data because say, for example, if a user has been, asked to punch a particular information in a warehouse. So there are warehouses where we found that manager will just block time before he goes home and he'll punch everything in one go.
So now, your timing information is not correct.
My timing information is incorrect, right? Now, there are media information that I have worked with where you have live stream data. The way the data comes in the backend is 5 minutes at a time because that is how the rights of that media was sold to the company. Now, when we look at the data to analyze, you have just 5 minutes data, right? Your playthrough rate will be 100% for every 5 minutes of data. Now, in this scenario, I have to do a lot of data churning for us to be able to get to that stage. So these are some of the things that we will do in the feasibility analysis. Right. Do I have data? And is that data even at the right quality for us to do it? Right. And third aspect is the governance aspect. Now, say, for example, your AI has learned from some aspects of data and something has gone wrong. Will I be able to trace it back and say, this part of the data is what gave me this solution, right? So that whole governance, traceability, quality, all that feasibility will be done. Third aspect is the infrastructure. Right. Now, we need the right kind of infrastructure, right kind of compute to be able to churn out the insights. Now, we cannot, there are remote locations where we might not be able to get that data on time, or there'll be temperatures which are like really at a minus some degrees that we are not able to capture data at the right level. There are manufacturing units where we try to predict whether that batch is going to fail or not by putting in sensors inside those machines. And it just doesn't work sometimes. Right?
The sensors don't work.
Sensors don't work, right? Because when it goes beyond a certain temperature, it just stops working. Now, my prediction will fail because we don't know whether that batch is going to be success or failure. So there are a lot of scenarios that we try to check. And the next part is, say we build that solution, how feasible will it be for us to adopt it quickly? Because typically, in back in those days, like when I started my career, we used to do projects for 3 months, 6 months, and everybody will be happy to wait for that, right? Today, you want a RAG in production in 2 weeks, right? Because they want to go to the market and the testing really happens
on the market,
on production, right? So that is really you don't have liberty of saying, I'll deploy 6 months later, I'll do monthly releases. So that stage is also gone. Like you have sprint level releases, correct. And you are testing in your second sprint, and then you are also building a new feature. That is how fast the ecosystem is, So that is also a very, very important factor. And how are we going to measure the value of the investment that we are going to put in? Right. Because generative AI, like I said, is very expensive, right? Like if you're using, any model from hyperscalers, then very quickly the costs can mount very high. Now, these decisions on whether we will use an open source model, we will use a hyperscaler model, what are the pros and cons, what kind of parameters we have to use, what kind of compute we will have to use, all these decisions happen in the discovery phase, which is, according to me, that's like the most critical part of the project. Because if we get this phase wrong, then everything else is going to fall apart. Once we do the discovery, then, we will start with the, data analysis, model building, and then testing, which happens very, very fast. The discovery is where we will have a lot of human element into the picture. But pretty much most of the codes that you require to build the forecasting model or test it out quantitatively, those are already available today with most of the organizations. So the build part does not take too much time. Discover, that takes time.
A naive but fun question is like, I mean, with all this hype with Gen AI, do you see this happen that in a discovery phase you tell someone that probably if this solution does not require Gen AI and people are adamant that they do want to solve it with Gen AI only?
Yeah, there were scenarios like that. So then we start showing the ROI calculator, right?
Okay.
So because if you can't speak with your knowledge, then you can
Speak with
money.
numbers.
So there was a scenario where we were trying to automate like cold calling, agents, right?
Yeah.
So there were like lot of call recordings that were available, and they wanted to completely automate it. Now the challenge here is there's one folder with 10 years of call data that is available. So there is no name for those files. There's like no
just
data. There are no transcripts. There's just nothing.
Yeah.
There's just a bunch of files. Right now, they're very adamant about using AI, and they had very tight budget of how this transformation should happen, etc. Right? But we felt that it just didn't. The numbers did not add up in what they were doing. There were different channels with which we could actually do it instead of AI, right? So by the time you process that data and create the solution, the value also will not be that high. So
correct. When
we try to explain, it didn't go well. Then okay, I'll open my Excel and start showing
how much it will cost
how
you.
much it will cost you. It's not from a professional service fee, right? It's from the infrastructure perspective. The infrastructure costs are sometimes higher than your professional fee itself. So once you start showing numbers, I think everybody gets back to the ground and they start realizing.
Right. Makes sense. I think I had this interesting conversation once I had on LinkedIn sometime. There was this junior from college who had like during COVID, like I think a couple of semesters exams did not happen in college, right? And so somebody had built something that I have taken the scores of everybody for the first 6 semesters and put it into a score prediction model. They had taken some open source model from I think Hugging Face, and then they had optimize it with the data from our college for the last 5 years. There were data of everybody's scores. So like given 6 semesters, somebody scores this marks, then 7th and 8th semesters, it will predict the scores. And they said that they had just made this project and they said that, okay, this year, these people who have not had the exams, we can take their last 6 semester scores, put it into my system, and it will predict what 7th and 8th semester scores would have been. So they can be given predictive scores or something like that. So I looked at their GitHub repository and their data, and this was like a person I knew only. So, and I had mentored him before. So I said that, hey, I looked at your data. Like if I just take the average marks of the last 6 semesters and I just put that average in the 7th and 8th semester, and my code is basically just a average function, if else average function. This is gonna run in like milliseconds for 500 students, and you require like CUDA and GPU to run whatever you are running, and my answers are exactly same as yours, because I mean, that's what happens in real life, right? If somebody is getting 70% for 3 years, they will get 70% in their 4th year. I mean, obviously there might be deviations, but then if those people had actually given the exams, then also there would have been some deviations, right? So you don't need to create a ML model to do score prediction when you can just regression, right? I mean, that's all it is. So I think sometimes people do, you use something like ChatGPT and OpenAI as a consumer level, and I feel like it's very magical, and you want to sort of use that somehow in every problem that you have, and you feel like it'll give you something magical, but sometimes the solution is sort of very out in the open.
And in my early stage of my career, once we told the customer he doesn't have to pay, because we built a very sophisticated model,
Yeah.
which was only 54% accurate.
Right.
So like you can just toss a coin and say
Yeah,
whether with 50% probability.
Yeah.
So after doing everything, like we still couldn't really, up the numbers because the patterns were not,
Right.
available. It was too diverse. We couldn't find patterns. So then we gave up, and at some point we told the customer, "Sir, this is not AI project. We are going to walk away."
Right.
So such scenarios have happened in the past. But today the customers are way more accommodating when your results are bad. Back then it was like,
I think the awareness helps that people understand
Correct.
that what kind of problems get solved and what don't get solved as well. Like that's
right. Once a customer asked, if it's a fixed price project, if the model is less than 85-90% accurate, you guys walk away with nothing. So from there to today, I think things have changed a lot.
Makes sense. To conclude on this, usage of Gen AI part is also there was like 1.5 years back when like GPT-3 and then very quick succession GPT 3.5 came, and then suddenly just because OpenAI was releasing, there was a lot of other people who were working on stuff like this. I think from Facebook opening up Llama to like Mistral and Anthropic, and everybody started jumping into this. I think there was quite a like the hype sort of peaked where people were just trying to ask random questions to, and if it's like a multiple billion parameters model, it starts giving you answers which are just not possible for like the layman who has been mostly used to something like Siri or OK Google, and this is like a step shift, and it's definitely magical, and people were like, okay, I can do this, I can do that. But I have started seeing even on my social media for people posting that, okay, so now that the hype is starting to die down, what is Gen AI really useful for? Because like, okay, I can play around with a chatbot and it gives me like, funny answers. I get it. But in an actual work or in real world scenarios where like, legitimate dollar cost reduction, is that happening with Gen AI? And people have started to question that, okay, we had fun for a year, but now where is it being actually used? So I'd like to ask that question that, where are some of the most impactful places where you're seeing like, in all seriousness, Gen AI being used to sort of really, let's say, reduce time of something by 90% or reduce cost by 90%, or somewhere where, and then the final products are also not just some funny pictures, but something actually useful, the generative models being applied for.
Right. The maximum usage we have seen is on the information retrieval part, right? Where you have like these clinical trial processes, there are like healthcare processes where there's a lot of manual digging of information that used to happen in the past,
right,
where we are seeing a lot of productivity, improvement, because these AI models are pretty accurate. In addition to retrieving and creating that content for you, it also gives you where it picked the content from. It gives you links. It actually points you to the places where that information came from,
right,
which also, creates more confidence to the customers when they want to understand, like, for example, terms and conditions, right? I'm sure you would have gone to any kind of a bank or insurance, and they give you like pages of information where
right,
we just don't have the patience to read, and maybe we will have questions, we will ask someone, and we just trust that whatever information they have is right. And I still don't know whether whatever answers I got was right or wrong, right? But today you can ask those questions to a bot and you can get answers with the links of where that paragraph was written or how it created or generated that information, right? That I think is a very, very powerful application, because this reduces the research work that happens in clinical trial processes and healthcare processes significantly, which directly translates into advancement in the medical field. So that's a big advancement that I think is very useful.
yeah.
And the second part is, of course, on these curated videos and images, right? Of course, it's used a lot for fun, and you'll see a lot of LinkedIn posts. But we are seeing that, these whole transition of career, for example, or L&D, learning and development.
Yeah.
We see a lot of value there as well, where you can generate very curated content for very specific use cases.
Right.
I had worked with some hyperscalers on generating AI-enabled BI. Right now, there are tons and tons of data. Like I said, there are data models that were generated when analytics and data science became very popular. But today, even if we have to churn those insights and get that information, you can use bots. Like if you see last 5-6 years, there are a lot of dashboarding work that we would have done. Now that itself has become a lot of information. You will have hundreds of dashboards that are available in your ecosystem. Now for you to bookmark everything and then have a UI to navigate to reach the dashboard that you want to look at, instead of that, you can just have a bot that's integrated with your teams where you can ask questions on sales or revenue or what is really happening, and those insights can be very quickly generated. But if you ask me, is this going to replace dashboards? No. There are executive dashboards where you don't need a very sophisticated generative AI, right? You have to know about 4 metrics every day. In those scenarios, dashboards still work as the cheapest option, right? You have an executive dashboard, you log in, or you just just open your laptop and you just see those numbers. That scenario I'm not talking about. Where you want information, like for example, quarter on quarter, what happened last year to this year, what happened, what are the nitty-gritties within a particular category that the sales is going down, what are the possible scenarios in which it could go down. These things you don't have to have hypothesis and then start churning the data. AI is able to do a better job at it. So these are the 3 scenarios where we are seeing a lot of productivity improvement. Rather, this AI-enabled BI, I have personally productionalized with multiple customers, and the hallucinations have reduced quite a lot. We've been able to do that very effectively on this particular use case.
Got it. Also, I think one of those places where, typically like the pitfalls of hallucinations are less as well. Something obviously wrong, if somebody just the summary is something obviously wrong, it's visible also that it is obviously wrong. It's not like ending up also with your customers, right? It's an internal dashboard and makes sense. On a concluding note, would love to ask a question on behalf of people who are in the data science field or they want to move, and then we have a lot of folks like that at Scaler as well who are learning and want to move here. So even let's say in your team, when you're hiring for people in your data science team, what sort of things are you looking for, and people who are in the data science domain working here for a few years, what kind of things do you think in the next, again, like you said, 5 years, who knows, but at least for the next 1 or 2 years, the direction that the industry is moving, what kind of things do you think people should focus on learning, focus on developing skills?
Sure. So like I said, I'm just going to repeat this again, right? Like problem solving, decision making, critical thinking is going to be a non-negotiable skill. And of course, communication and articulation.
Correct.
Like I said, in discovery phase, you need to ask the right questions. You need to have curiosity to truly understand a customer's process or any process for you to really tell them that, okay, this is where you are going to be able to, infuse AI into it, right? So that is going to be one of the very, very critical skills: curiosity, communication, and articulation. Now, if I come to the technology part, right now, understanding what kind of coding assistants are available, what kind of models are available, that awareness and being able to read, follow through some of the blogs and keep up with the trend to really know where I can directly use a model versus where I need to go and build it from scratch. Prompt engineering is something that everybody needs to understand, because that is a skill that will be very, very critical, because more and more the foundational models are becoming better and better. We should be able to solve a lot of problems just with prompt engineering. So prompt engineering, knowing when to use prompt engineering, RAG, and fine-tuning is also going to be one of the critical skills that everybody needs to understand. And just, being aware of the terminologies, right? Because a lot of terminologies also keep coming up in the market. Like, for example, I told you about when hallucination came in, a lot of customers were just asking us, okay, what is RAG? What is hallucination? What is contextual forgetting, right? So it's important for us to keep up with what is this all about, and have that curiosity to go back and see how RAG really works in the backend. right? Not many of the next gen is really interested in what happens in the backend. As far as you're able to integrate a bot with your API call, do some API calls and show some output, they just are happy with that. Right now, it is important for us to know what happens in the behind. Because that will come a long way. Most of the technology advancements happens from where you are at currently. So if you
Correct.
don't have a good understanding of that, you're going to be left behind. 10 years down the line, it will be way more advanced, where only application alone will not really, make us a good data scientist. That is good enough for some roles, but if they want to become a full stack data scientist, that is going to be a skill they need to pick up. Then comes your engineering skill. Like I said, you need to know at least some part of data engineering, some part of testing. You need to understand how does this sit within a product, right? Because none of the data science models today are just for decision making. It's always integrated with a product or a process or a platform. So it is important for them to have the basic understanding of software engineering lifecycle, data engineering lifecycle, how all of this comes together. What kind of choices should I make as a data scientist, which will bring in the right kind of outcomes with the better cost efficient architectures.
Yeah.
So that becomes the next skill. Then the last part, of course, is understanding the governance, regulations, for what model, what kind of governance is required, because it's not a one size fits all today, right? So you don't just go and just talk about model performance. Right now, they will still ask us, what is the trade-off between model performance and your governance? So there are these nuances that you will have to understand. And the last and the most important skill is to pick up a cloud technology, right? It can be Azure or AWS or Google, but picking up at least one cloud hyperscaler and understanding the end-to-end stack will be very important for them, because there are very, very less number of projects that are still, happening on the legacy systems.
Right.
So it's important for them to understand cloud security, and how all of these different layers happen within a particular cloud. So that is also a very important skill.
Got it. I think that's a great set of advice. I'm sure people who are looking forward to either enter this field or grow in this, I think this will be supremely helpful. And you think that the opportunities in this space will definitely increase?
Yes, of course. We are just getting started.
Just
This is the new era of AI, and we are just getting started.
Nice. Thank you for taking out your time and answering all of these questions. I'm sure it would spark more curiosity also in people who are interested in this to learn more about. And I myself am also very excited in seeing these AI powered solutions getting implemented. Definitely, I'm seeing a lot of places in where I work and my team. This is increasing productivity to even enabling us to do things which was just simply not possible before. So yeah, I think exciting times ahead.
Nice.
Thank you for coming, and thank you for answering all the questions.
Thank you. It was a great experience. I think it was nice meeting you and the entire team. Looking forward to connecting further.
Sure. Thank you.